Hey guys, so I want you to check this problem out right here. So it says write the equation of the cubic function graph to the left. Okay, so I'm asking you basically to go backwards from what we've been doing in class. So we've been giving you a function and then giving you the factored form of that function, and you've been using the degree and the leading coefficient to actually graph that given function. So now we're giving you the graph and seeing if you can go backwards. All right, so we used the factored form of each equation to tell us our x-intercepts or our zeros, right? And those are the places where you cross the x-axis, correct? So if we look right here, I see two places where I'm crossing the x-axis, okay? I see this value of x equals -4, and I see this value of x equals 2, okay? So this is asking me to write a cubic function. Cubic means that it needs to have an overall degree of 3, right? And the fundamental theorem of algebra tells us that if the degree is 3, the number of solutions that we're going to have is 3. Well, if I look over here, I see 2 on the graph. I see -4 and I see 2. All right, but I noticed something right here at this -4. Do you guys notice that this is bouncing right here? So we know if we see a bounce, that means that there has to be an even multiplicity of that number. Okay. All right. So I'm only crossing twice, but I see that one of them is bouncing. So that means that that solution is happening 2 times. So x equals -4 is happening twice, and then x equals 2 is happening once. So that's 3, right? Those are my 3 solutions. So I got to figure out how I can use these solutions that I have to write a factor that gave me that solution. So if I look at this first one, this x equals -4, I got that x equals -4 by taking a factor, x plus some number or x minus some number, setting it equal to 0 and solving. So I need to try to figure out, well, how could I go backwards? So if I got x equals -4, basically, if you were to add 4 to both sides, you would get x plus 4 equals 0, right? Well, hey, there's your factor. So the factor of x plus 4 gives you a 0 of -4, okay? So the other one, you had x equals 2. Okay, so if I were to go backwards here, if I moved that 2 over, you subtract 2 from both sides, you get x minus 2 equals 0. So the factor that gave you x equals 2 is x minus 2. So I now know factors, right? All right, so I need to kind of think for a second. I said this x minus 4 over here has to bounce. So if it bounces, it's got to have a multiplicity that's even. So we said that if the total degree was 3, that means that the exponents need to add to give me 3. So I can assume this x plus 4 needs to have a degree of 2 because we bounced there. And then I have this x minus 2 as a factor. So here, a degree of 2 plus a degree of 1 equals the total degree of 3. So we've got that. So this, if we multiplied this, if I FOILed x plus 4 squared and then multiplied that by x minus 2, it's going to give me a cubic polynomial. So now I need to kind of make sure that this is exactly right. So look at your end behavior. Your end behavior is down on the left and up on the right. So that is a positive leading coefficient, right? So I don't need to, if it was a negative leading coefficient, I would need to put a negative out here in the front. But because this is a positive leading coefficient, this is what I'm looking for right here. So that would be the equation of the cubic function that's graphed right there on the left side. All right, I want to do one more real quick. All right, so if you look at this one, this says a quartic function. Do you guys remember what that is? That is a degree of 4. Okay, so fundamental theorem of algebra tells me that I need to have 4 solutions if the degree is 4. You can also kind of make notice something too about this graph. Look at the end behaviors. It's down on the left and it's down on the right. So it looks something like this, right? So isn't this an even degree with a negative leading coefficient? Okay, so I could go ahead if I wanted to and say, hey, I know no matter what those factors are, I know that something in the front is going to have to be negative because this is an even degree and it's got an x-axis reflection. All right, so I'm going to go back and find the solutions like we did just a second ago. I'm finding those zeros. So the first one is x equals -6. This one is x equals 0, and this one is x equals 3. Okay, so I'm going to come back here. So x equals -6. The factor, if I add 6 to both sides, I get x plus 6 equals 0. So there's one factor there. I'm going to come to x equals 0 in a minute. I'm going to go to x equals 3 first. So x equals 3, if I move this 3 to the left with this x, I get x minus 3 equals 0. So there's another factor. Okay, and at -6 we crossed, and at 3 we crossed, and if you notice, they're both just crossing through, so we can assume that those have multiplicities of 1, right? So here's one solution, two solutions. Then I go to this x equals 0. Do I need to move anything there? If I move 0 to the left, I get x plus 0 equals 0, and we know we don't really write that. So this is just x equals 0. So your factor here would be this x, which we've seen when they're out in the front, right? When you factor it out. But there's something special going on right here. So we see that we have a bounce here. So that means that you need to have a multiplicity that's even, right? So if I had a quartic function, that means that the overall degree is 4, and I've already got 2 solutions here, okay? 4 minus 2 is 2, so that means that this right here needed to bounce and have a multiplicity of 2, so that 2 from this, so this happens twice, plus 1 gives you this total degree of 4. Okay, so I'm going to come back and I'm going to write this out. So this is really like having a factor of x squared equals 0 because of that bounce that we saw. Okay, so don't we usually, we've already said we had a negative leading coefficient, so I've got that out front. If I ever have an x by itself, don't we usually see that in the front before the other factors? So I'm going to go ahead and take care of that first. So negative x squared, and then I'm just going to bring in the other factors, times x plus 6 times x minus 3. And if you were to multiply all that out, it would give you a polynomial function that has a negative leading coefficient and an overall degree of 4. So when you're asked to write the equation of, and it's just a possible equation, right? If you're asked to write that equation, just do it in factored form. That's it.